Okay, guys, in this video lesson, we're going to start talking about momentum and get into impulse in a future one, okay? So as we move forward here, momentum is a new term for us. It's not new to our everyday speech. We've talked about momentum before, right? Usually when you think of something that has momentum, it has movement, it's something's going on there. Maybe like in sports, you talk about, hey, that team has the momentum now, that kind of stuff. And all those are good connotations towards our word momentum. In the physics world, we define it like our other terms that we've been finding out, that it has a very specific meaning to us, okay? So now the definition itself might seem a little bit vague, but really, it's all it really is, okay? Momentum is the quantity of motion, okay? Now, if you take a look at our world, if something is moving, it has momentum. If something that has mass and a velocity has momentum to it, all right? Now, the nice thing is they're both linear regressions, okay? So as you increase velocity, your momentum increased proportionally. As you increase your mass, your momentum increases proportionally, okay? So if you look, they're really nice straight linear regressions, which means our equation is going to be very simple here, okay? One thing we want to make a note of is that momentum is a vector quantity, which reminds us that vector quantities are direction dependent, meaning that if you're moving to the right versus the left, we need to make sure that we're identifying one of those two directions as either positive and the other one as negative, okay? So our equation for momentum is P, and that P symbol is our symbol for momentum, okay? It's often referred to as meaning progress. So things that make progress have momentum to them, okay? It's just our mass times our velocity. That's all it is, okay? If you have mass and you have velocity, you got momentum. That's pretty simple as we go forward. There's no special unit for momentum. Again, it's just your kilogram from your mass, and your velocity is meters per second. And that's all it is, all right? So momentum is really pretty fundamental in the world of physics. It really is a way that we can give a representation of what type of motion or that quantity of motion something has when it is moving at a certain velocity and has a certain mass to it. So let's do a simple practice problem with this, all right? So if I have an object, let's say it has a mass of 50 kilograms, okay? And it's moving at 10 meters per second, okay? If I got 50 kilograms, and I'm moving at 10 meters per second, well, to find the momentum of that object, we're going to take that 50 times that 10, right? And the momentum of our object is going to be 500 kilogram meters per second, okay? Now, if that same object, okay, let's say it slows down. So it was going 10 meters per second, but now it's only going at 5 meters per second. What's its new momentum, all right? So, our first calculation was pretty straightforward. We had 50 times 10, we were good. But if we slow it down to 5, you could recalculate this, right? You could take, okay, I got 50 times 5 now, and that's 250, kilogram meters per second. However, we should be able to recognize the fact that we went from a momentum of 10 to 5, where we have half the velocity, okay? So if you half the velocity, so we were going 10, and now we're going 5, if we have half the velocity, we should have half the momentum, okay? On the same token, if we say we have two objects, and let's say they're both moving at the same speed, they're both going 10 meters per second. If one object has a mass of 100 kilograms and the other object has a mass of 50 kilograms, well, if they're moving the same speed, the object that is more massive will have more momentum to them, okay? So one thing we want to make sure that we're careful about is not only being able to use the formula, but also be able to conceptualize what happens if we have a comparison between high speed, low speed, high mass, low mass, those kind of things, all right? We don't want to get into this rut of thinking that, really big things always have a lot of momentum, okay? Not true, right? You can have a gigantic Mack truck, and if it's barely moving, it doesn't have much momentum behind it. At the same token, you can generate some momentum by having things move very quickly between them. Neither one is more important than the other one. Neither one has a bigger mathematical multiplier. They both use in conjunction with each other. All right, so that's momentum. Now, we're going to end the video lesson here because in our next slide, we're going to start talking about conserving momentum, and we want to do a separate lesson for that. Thank you.